Hello, Sam Butchart here again with the second video tutorial on deductive validity. So far the arguments we've looked at all began with a first premise which was stated as a conditional statement, if A then B, but consider this argument. Anyone who lives in Melbourne lives in Victoria. Joe does not live in Victoria, therefore Joe does not live in Melbourne. This is fairly obviously a deductively valid argument, and it's very similar to an argument that we saw before, but notice that it does not have an if-then statement as the first premise. Nonetheless, that first premise does mean the same thing as an if-then statement. Here it is again. Anyone who lives in Melbourne lives in Victoria means the same thing as this. If someone lives in Melbourne, then they live in Victoria. So we do have an if-then statement as the first premise, although this is now a general statement rather than a specific statement about Joe, for example. It says that anyone who lives in Melbourne lives in Victoria. And now our second premise says that a particular individual, Joe, does not live in Victoria, and we conclude that Joe does not live in Melbourne. So the pattern of argument is this: if A then B, or all A or B. If someone lives in Melbourne, then they live in Victoria, and some particular individual, X, is not B, Joe does not live in Victoria, therefore that individual X is not A, Joe does not live in Melbourne. And this form of argument is valid if the premise is true. If all A are B and some particular thing is not B, well then it can't be A. Again, you can see that from this kind of diagram. Here are the A's, and all of them are B. That represents the first premise again, all A are B, or if something is A, then it's B. And if X is not B, not one of the B's, well, it can't be one of the A's either, which is what the conclusion says. So this is a valid form of argument, and it is in fact just modus tollens again, just a slightly generalized form of modus tollens. The valid form modus ponens also comes in a generalized form, looking like this. Here's an example of it. All Australian citizens are eligible to vote. All A are B, or if someone is A, then they're B. And some particular individual is an Australian citizen, X is A, therefore that individual, Tom, is B, X is B, eligible to vote in this case. So this is the valid pattern modus ponens again. All A are B, or if something is A then it's B, and some particular thing X is A, therefore that thing is B. Valid form of argument. And again, you can see that it's valid by thinking about this kind of diagram, which represents now all A or B. Anything that's in the A circle is in the B circle, and if X is in A, then X is automatically in B. So here is a table showing, first of all, the valid forms of argument that we've looked at. The simple form of modus ponens, if A then B, and A is true, so B is true. And the generalized form of modus ponens, all A are B, and some particular thing, X is A, therefore that thing is B. Here's the simple form of modus tollens, if A is true then B is, but B is not true, so A isn't true. And here is the generalized version of that, all A are B, X is not B, therefore X is not A. Equally, the invalid forms of argument that we've looked at, affirming the consequent and denying the antecedent, also have generalised forms. Here's the simple version of the invalid pattern affirming the consequent. If A is true, then B is, and B is true, so A is. And here's the generalised version. All A are B. X, some particular thing is B, so that thing is A. This is invalid. Likewise for denying the antecedent, here's the simple form. If A then B, A is not true, therefore B is not true. And here is the generalised form. All A are B. X, some particular thing is not A, therefore that thing is not B. Also invalid. So, quiz question for you. Here's a little argument, not a serious argument, but it makes the point. All cats have 4 legs. I have 4 legs, the doggy is thinking. Therefore, I am a cat. Is that valid or invalid? Modus ponens, modus tollens, affirming the consequent or denying the antecedent. So just pause the video here. Think about your answer before you go on. It is, of course, invalid. I'm sure you got that right. And it's the pattern affirming the consequent. All cats have 4 legs. All A are B. I have 4 legs. That's saying X is B, where X, of course, in this case is this dog. Conclusion, X is a cat. X is A. So the pattern is all A are B. X is B. Therefore, X is A, which is the invalid pattern affirming the consequent. So if you're given an argument and you're trying to work out which of the common patterns of argument it fits, let me suggest 4 steps to go through to work that out. I'll use this very, very simple example to illustrate the steps, but it will work on more complicated and difficult examples too. Step 1 is to just read through the argument and make an initial decision about whether you think it's valid or invalid. You might want to change your mind later, but make an initial judgment about the validity of the argument. Second step, well, if you thought the argument was valid, then pick which of the valid forms you think is going to be the best fit for it. If you thought the argument was invalid, you'll pick one of the invalid forms and try that out. So in step 3, you try to fit the argument into that form. You'll check to see whether it works or not. I'll explain how to do that. If it does fit, that's good. If it doesn't fit, go back to step 2. Try one of the other forms. If it's still not working, it may be that your initial judgment about validity was wrong, so you should go back to step 1. And if you initially thought it was valid, but it's not fitting any of the valid forms, then maybe after all the argument's invalid. See if you can get it to fit one of the invalid forms. Equally, if you initially thought the argument was invalid, but it's not fitting any of the invalid forms of argument, have another think about it and try to see if it will fit any of the valid forms of argument. So let's work through those steps using this simple argument. You'll see I've changed it slightly so that it says my dog instead of I. That's just to make things a bit simpler. So step 1, read the argument and decide whether you think it's valid or invalid. So I look at this argument and I think, that looks pretty invalid to me. I might change my mind about that later, but for now I've made an initial judgment and I'm going to see if I can get it to fit one of the invalid forms of argument. So step 2, pick the valid or invalid form of argument you think best fits. Well, I thought this was invalid, so I'm going to pick one of the invalid forms. It's going to be either affirming the consequent or denying the antecedent. Let's begin by trying denying the antecedent. this won't work. This isn't denying the antecedent, it's actually affirming the consequent, as we saw before, but we'll see how the steps that I'm outlining will help you get the right answer. So I start by trying to fit the argument I've got to the form denying the antecedent. Here's the generalised form of denying the antecedent. All A are B, X is not A, therefore X is not B. Well, my first premise says all cats have 4 legs. If I'm representing that as all A are B, then A is going to be cats, and B is have 4 legs. X is going to be my dog. So I have all A are B, my dog is not A, therefore my dog is not B. Okay, I've tried to fit it into that form. Now I'm going to check that it works. How do I do that? So here's how you check it. According to this, the first premise is all A are B. A is cats and B is having 4 legs. So this should mean all cats have 4 legs. If A is cats and B is having 4 legs. And then we check that that is what the first premise actually says. And it is. It does say all cats have 4 legs. But now let's look at the second premise. We have here X is not A. Well, X is my dog and A is cats. So X is not A should mean my dog X is not a cat. So then I check whether that's what the second premise says. But it isn't. The second premise does not say my dog is not a cat. The second premise says my dog has 4 legs. We can also check the conclusion. X is not B. Well, if X is my dog and B is having 4 legs, this should mean my dog does not have 4 legs. But again, that's not what the conclusion says. The conclusion says my dog is a cat. So it doesn't look like this fits the denying the antecedent pattern, so let's try again. Well, I'm not yet ready to give up my idea that this argument is invalid. In fact, I know it must be invalid because the 2 premises are true. All cats have 4 legs, and my dog, being a normal dog, does have 4 legs, but the conclusion's definitely false. No dog is a cat. So no valid argument can have true premises and a false conclusion. That's just from the definition of deductive validity. A deductively valid argument is one where if the premises are both true, the conclusion must be true. Here we've got true premises and a false conclusion, so it can't be deductively valid. So I'm going to try one of the other invalid forms, affirming the consequent this time. Here's affirming the consequent. I'll just write it out. All A are B, X is B, therefore X is A. Well, let's see if I can get this to fit. All A are B, all cats have 4 legs. Again, I'm going to pick A, cats, B having 4 legs. And now let's check that that works. The first premise here says all A are B, which means all cats have 4 legs. And again, that gets the first premise right. Now, the second premise says X is B. Well, that should mean X, my dog, is B, a creature with 4 legs. My dog has 4 legs. Is that what the second premise says? Yes, it is. That's exactly what the second premise says. And now we look at this conclusion. X is A. Again, X is my dog. A is cats. So this should mean my dog is a cat. Is that what the conclusion says? Yes, it is. It says my dog is a cat. So this argument we've now shown does fit this pattern, affirming the consequent. So here are those steps again. First, read the argument and make an initial decision about whether you think it's valid or invalid. You might change your mind later, but make an initial decision. Then pick the valid or invalid form you think is going to best fit the argument and try to fit the argument to that form. Then, and this is the crucial step, check that it works in the way that I explained. If it does work, that's fine. If it doesn't work, go back to step 2, pick a different form, try again. If you still can't get it to work, it may be that your initial judgment was wrong, so go back to step 1 and think again about whether you think the argument's valid or invalid. If you initially thought it was invalid, try now to see if you can get it to fit one of the valid forms of argument. If you initially thought it was valid and that's not working out, try to fit it to one of the invalid forms, see if that works.